All right, so 9.4 is going to conclude chapter 9 for us. We'll have learned our third type of hypothesis test, and we'll be ready to move on from there. So our third type of hypothesis test is a hypothesis test for proportions. How do we do it in the calculator? We hit stat because it's stats class. We go over to tests because it would be useful on a test, and we select one prop z test because remember, our test statistic is a z statistic, and we have just one proportion, just a single proportion, just one p. So I think there's 3 homework problems that I assigned. One is just like a really generic one. That's the one I'm looking at right here. So that's number 9 on page 467. So number 9 just says we have a random sample of 80 somethings. Of these 80 somethings, 54 were in a quote category of interest. And then it kind of sketches out some additional information. So here it looks like we're testing whether or not the percentage of people with this characteristic of interest is less than 80%. It looks like that's what I've set up in the calculator. Then I go down to calculate, I hit enter. Just like before, right? There's our step 2 and our step 3. Our test statistic is negative 2.8. Our p-value is 0.002. So our test statistic, right, we would say that the sample proportion is 2.8 standard deviations below the hypothesized proportion. And then our p-value being very, very small, 0.02, or I guess technically we'd round that up to 0.03. Our p-value of 0.03, 0.003, sorry, means that that it's very unlikely that we would see a sample proportion as smaller than the one we just observed, if in fact the true proportion was 80%. Now notice for the one prop z test, it also gives us that p hat. So underneath our p value, you see like p hat, and it says 0.65. 0.65 or 0.675, sorry, 0.675 incidentally is that 45 divided by 80, as we'll see on the other slide. So the book's first question actually is compute the sample proportion p hat. The calculator did that for us. Not that it's very difficult to do on our own, right? We had 80 individuals, 54 of them had the characteristic of interest, so 54 out of 80 is 67.5%. We already observed the test statistic was negative 2.8. We already observed that the p-value was 0.0026. That's less than 0.05. So we reject the null hypothesis at that 0.05 level. What does that mean? It means there's sufficient evidence to conclude that the population proportion P is less than 80%. So that's just practicing kind of just I guess the motions. Let's try it in the context of a word problem, which again is probably more like what you would see on a test. All right, so according to Secure List, which I guess is some email company, 71.8% of all emails sent is spam. How scary is that? Although truth be told, I probably would have guessed it was larger than that. Oh, well, actually, hold on. Hold my beer. A system manager at a large corporation believes that the percentage at his company might be 80%. Whoa, what the cut the? He examines a random sample of 500 emails received at an email server and finds that 382 of those 500 are in fact spam. So it says state the appropriate null and alternative hypothesis. Here, I have to admit, I actually found this one like a little bit vague, this 13. I actually had to cheat and look in the back of the book. I felt it wasn't super direct about what it wanted us to test, but looking at the back of the book, it appears that it wants us to test this system manager's claim. So the system manager believes that it's 80%, and we think it's maybe something other than 80%. And so that's why we're going to do P not equal to 80%. It's good to have one of those types of problems. I think in our homework, we haven't had a not equal to example, and you're certainly going to get at least 1 or 2 of those on your exam. I will say that this particular question was phrased a little vaguely in terms of setting this up. So if you didn't set this up correctly yourself, I wouldn't give yourself too much of a hard time about it. On a test, I'll be more explicit. I'll say something like, right, the p-value, the system manager thinks it's something other than 80%. That would be maybe how I'd phrase it on a test. So here I am filling in the information, right? Oh, there's that 80%. That's actually the same as the problem we just did. So our P naught is 80%. 382 emails were spam. That was out of 500 emails. That bottom line, we're picking our alternative hypothesis. Our alternative hypothesis is not equal to P naught. We put the cursor over calculate and hit enter. And there's everything we need. So looks like our p hat is 76.4. So of our sample of 500 emails, 76.4% were spam. So a little less than 80%. Our test statistic is negative 2.01. Our p-value 0.044. So right, very, very close to 0.05, but still technically less than it. All right, so B, what's our test statistic? That's easy, that's straightforward, that's negative 2.01. C, it says, what's our conclusion? Actually, C and D, like in C and D, they actually make the alternative hypothesis a little bit more explicit. However, right, to be able to answer B, we technically would, at least using our calculator, we would have needed to know the information in C and D. So I still think this is a slightly poorly written problem. Our p-value is 0.044. That's less than 0.05. So if we were using 0.05, we would reject the null hypothesis and say the percentage of spam is different than 80%. However, D says, well, what if you were being a little bit more stringent than the usual 0.05? What if instead you were using 0.01? Well, in this case, our p-value is now larger than alpha. Anytime our p-value is larger than alpha, we fail to reject the null hypothesis. In the context of this problem, that means that there is not sufficient evidence to conclude that the percentage of spam is anything different than 80%. All right, red light. Red light means stop. So if you haven't already, make sure you solve problem 15. I'll sit here and wait for you. All right, good job. Let's go ahead and check our answers together. So a marketing manager for a cell phone company claims that more than 55% of children aged 8 to 12, my goodness, have cell phones. What are they doing with those cell phones? In a survey of 802 children in that age range, 449 had cell phones. So using this information, what do we think about the manager's claim? So claim that more than 55% have cell phones. Now, right, there's not one thing to boldface here, but we're looking at percentages, right? We look at a particular child. A child either has a cell phone or doesn't have a cell phone. And we want to know the percentage of all children that have cell phones. So that's going to be a test of proportion, right? That's what's guiding us to do the one prop Z test. So here we are filling in all that information. Our P naught, our hypothesized proportion is 55. We think it might be more than 55. So we plug all that information in. Here's our information right here. So it looks like that P hat is like 55.9, so about 56%. So it's a little bit above 55, but not a whole lot. Our test statistic is 0.56. That's not a lot. So that's like half a standard deviation. So we're saying that the sample proportion is about half a standard deviation above the hypothesized proportion. That's not really a big difference. So not surprisingly, the p-value is also quite large, 0.287. So our p-value is 0.2875. That's quite a bit more than 0.01, which is the alpha they want us to use. And so that means we fail to reject the null hypothesis. There is not enough evidence to conclude that the percentage of children using phones is more than 55%. I don't know how you feel about children ages 8 to 12 using cell phones, but I guess I'm going to say that's good news. I got a 4-year-old. It's hard to imagine him using a cell phone 4 years from now, but I guess that's what I have to look forward to, and perhaps you too someday.